All right, let me work through the first example in this section. This section is about higher order derivatives. So we know when we take the derivative of a function, we get another function. So then we can keep on taking the derivative of the new functions as many times as you want. So let's just find the higher order derivatives of a function f. This function f is x to the fifth minus 3x to the fourth plus 4x cubed minus 2x squared plus x minus 8. So let's just take the first derivative to start. And then we just, keep on taking the derivatives of the functions we are obtained, or the derivatives we obtained. All right, so the first derivative of the function, we use f prime to denote it, as we know. And so that's just equal to the derivative of each part. Okay, so when you take the derivative x to the 5, you use the power rule. So you do the same thing for the other terms. So let me just explain in more details about that. So the first term is x to the 5. The second term is the derivative of 3x to the 4th. Okay. And the third term is 4x cubed. So we just change these numbers. And then minus the derivative of 2x squared. And the derivative of x, the next term. And finally, minus the derivative of 8. We all know that it will be 0, okay? So just do the term by term. So the first term, the derivative of x to the 5, we use the power rule. So n equal to 5. So the derivative of x to the n is n times x to the n minus 1. So that'll be 5 times x to the 5 minus 1, which is 4. And then we subtract, we can take out 3 from the second term, minus 3 times x to the 4th prime. And the third term, we can also take out 4 from the inside. So that'll be 4 times x cubed prime. And then the next term, derivative of 2x squared, we can take out 2 from inside. So that'll be 2 times the derivative of x squared. Okay, and the derivative of x is just 1, as we know, so let's just do that. And derivative of 8 is 0, so minus 0. Okay. So, okay, so now just finish this term by term. So the first term is 5x to the 4th. The second term is minus 3 times due to x to the fourth, so that'd be 4x cubed if you use the power rule as we did in the first term. So the n is 4, so the derivative of x4 is just the 4 times x, so 4 minus 1, so 4 minus 1 is 3. The next term plus 4 times x cubed prime, so that'd be what? 3x squared is negative. You you know, treat n equal to 3, and the derivative x3 is just 3 times x times 3 minus 1, which is 2. So that's why we got 3x squared in here. And the next term, we already know how to do it. I think we did it before. The derivative of x squared is just 2x, or 2x to the 1 if you want, but that really doesn't matter. Okay. 2x n equals 2, so n times x to n minus 1, so 2 times x to the 2 minus 1. 2 minus 1 is just 1, so that's x to the 1, or x, simply. And then we got 1 at 8, and we don't have to worry about the 0. Now, we can write down the final answer. So the first term is 5x to the 4th. Sorry about it. What's going on? And the second term is just 3 times 4 is 12, so that's 12 minus 12x to the 3rd. And the next term, 4 times 3 is 12, and 4. So we got the plus 12x squared, all right? And then the next term, it's what? It's 2 times 2 is 4, so that's negative 4x. And finally, we get 1 here. Okay, so that's the first derivative. Pretty straight. Okay, let me just try to combine. Those two lines together. Doesn't work. Okay, so that's fine. I will keep it as it is. It will it will do itself automatically later. Okay, so that's first derivative. 5x to the 4th minus 12x cubed plus 12x squared minus 4x plus 1. So let's just do the second derivative. So we're trying to find, the higher order derivatives. So for the second derivative, we use the double prime. So f double prime is just a derivative of f prime. So let's just do it directly. So the first term, we got the 5x to the 4th. So keep 5 in here, and then the derivative of x 4th, we already did it. So that's 4x cubed, isn't it? So let's just copy it. And the next term is x cubed. We take the derivative of x cubed, we got 2x squared, isn't it? I mean, Not 2x squared, 3x squared, I'm sorry. So, okay. 3x squared, yes. Oops. Copy the parentheses. So that's the second term, and then we got 12x squared. So 12 to do the x squared is just 2x, so we already did that. So I'm not going to repeat that. And the derivative 4x, you know, we know the derivative x just the 1. Here, okay, so that's 1. 4 times 1. And the last term, the derivative 1 is just 0, so plus 0. So we can simplify the answer. 5 times 4 in the first term, so that's 20 times x cubed. And second term, negative 12 times 3, that's negative 36. So times x squared. Negative 36 times x squared. And the third term, 12 times 2x. So that's 12 times 2 is 24. So that's 24x. Oops. Plus. Okay. And 4 times 1 is just 4. That's 4. Right? So that's f double prime. We don't have to worry about the 0, as I said. So that's the second derivative. And then we can keep on taking the higher order derivatives. So if triple prime, so that's the third derivative. Third derivative, we use 3 primes, triple prime, to denote third derivative. So again, we just take the derivative of this second derivative. So we got 20 times derivative x cubed, and x cubed, we already did this, so that's 3x squared, right? And then minus 36 times derivative x squared, which is 2x. Plus 24 times derivative x, which is 1. And finally, we get the derivative 4, which is 0. So that's it. We can simplify the answer. 20 times 3, so that's 30 or 60 x squared. Okay, x squared. And 36 times 2, so that's 72. So that's 72x, like plus 24. Okay, so we don't have to worry about 0. Now, what's the next? The fourth derivative, right? We're going to do the fourth derivative. Okay, for the fourth derivative, we don't use 4 primes. Instead, we just use 4 inside the parentheses. Oh, wait. So that's the notation for the fourth derivative. So they use the parentheses 4, okay, on the shoulder wave. So that means the fourth derivative. We just take the derivative, the third derivative f. So we take the derivative of this function 6x equals 60x squared minus 72x plus 24. So 6 times derivative x squared, take the derivative, we got 2x. Okay. We already did all of those. And minus 72 times derivative x, which is 1. And derivative of constant 24 is just 0, so plus 0. So we can easily, simplify it. 60 times 2, that's 120. So first term is 120x. And okay, 72 minus 10 times 2 is times 1 is just 72. Okay, so we don't have to worry about 0. So that's the fourth derivative. Now we can continue with the fifth derivative. All right. So let's 5 in here. So use the parentheses 5 on the shoulder wave to denote the fifth derivative of x. So we got 120 times derivative of x, which is 1. And derivative of 72 is just a 0, so 0. So at the end, the answer is just 120. Okay. And then we can keep on doing this. So we can take the sixth derivative of the function. All right. So that's but we only get 120 for the fifth derivative f. So that's constant. So we are taking the derivative of the constant 120. So we're going to get 0. So then if you keep on taking the derivative of, this 0, you're going to get 0 again and again. So the seventh derivative of the function is 0. And the eighth derivative function is 0. And all the higher order derivatives following that will be 0. So for all what? N greater than or equal to 6. Okay. So the derivative equals 0. The higher order derivative as a function as n greater than or equal to 6 is 0. All right. So that'll be the end of this example. So let me just make a little better for the answers. Okay. So that's the example.